All right.
Thank heavens.
All right, so we're going to start off with the pop quiz. The quiz is the overall prevalence estimate, which is circled here, is it statistically significant or not? Since today's session is about p-values and inferential data, well, let's just start off the bat. Is the overall prevalence, which is in red, is it statistically significant or not? We need quick answers. We don't have all day. Any answers? Let me see if there are any things in the chat.
Significant.
Okay, we need two people to voice, one person who argues that it's significant to tell us why it's significant, and one person who says it's not significant to tell us why it's not significant. So we need a volunteer on either aisle. Again, the question is the overall prevalence statistically significant? That's the question, and it's on the screen as well.
How? Haruna?
Good evening, Prof.
Hello.
Please, can
Okay, am I on?
Yes, we can hear you clearly.
Okay, so thanks for the opportunity. I think the data gotten after the overall is based on the overall numbers that you've cycled. So it's very, very significant. It's like a screenshot of all the other data combined together.
Okay, thank you very much. The next person, next respondent.
Huda.
Yeah. Good afternoon. The confidence interval does not contain 0. So I think it is not significant.
All right, thank you. One more answer.
Isaac.
Yeah, good afternoon. Thank you for this opportunity. I'm not seeing any significant test done, which is the p-value. So at this moment, I cannot conclude whether it is significant or not. Thank you. Over.
All right, thanks. One last person. I'm really looking to hear something which I've not heard. So the last person I will proceed.
Gabriel.
Yes, for me, I can say it is not significant, because if you see this overall data, the one is 21.3 and the other one is 19.2, and all of this one, they are greater than 0.05 level of confidence, which is 5%. This is the reason that I can give.
All right, thank you. All of you are very, very wrong. The reason why all of you are, so the answers were, oh, it's significant or it's not significant. The only answer is that this question is a nonsensical question. The question makes no sense. All right, now, who can tell us why this question is just nonsensical and it's very, very hard? It makes no sense. Why does it not make any sense?
Prof, I'm sorry to disturb you. While you wait for their responses, or while you listen, can you please, we've seen that you're the only person who can deactivate the annotation feature for everyone. As the person sharing this.
Oh, really?
Thanks.
Okay, let's see. How do I do that? Presenter view. Let's see.
So in the meantime, Michael or Mikhail.
Okay, thank you for giving me this chance. And I would say we can say significant or not significant as far as we don't know the p-value. So it is sent as far as the p-value is not given.
Okay. All right. The presence or absence of a p-value is not what makes the question nonsensical. When we have a p-value, it means that we are comparing two things. That's what a p-value means. A p-value means we are comparing two things, right? Look at the question again here. The question says, is the overall prevalence statistically significant? All you have is one number. So when we say the overall prevalence, what are we comparing it against? Nothing. The estimate is just there, and we're not comparing it against anything. So that is lesson number 1 of the day. So if you don't learn anything today from today's class, if you can take home that if you have a p-value, it means you're comparing two things, right? It's a different thing if we were comparing men and women in terms of their tobacco prevalence. But here, the question specifically says the overall prevalence. Another point I wanted to draw from that is that don't get confused by confidence intervals. Confidence intervals serve different purposes. The use of confidence intervals in descriptive analysis is very different from the use of confidence intervals in inferential statistics, right? Very different. When it is inferential statistics, we can look at the confidence interval and say, oh, it includes 1 or it does not include 1, so the result is significantly different. Sure, we can do that when it comes to inferential statistics. But this is descriptive. This is saying the percentage of persons, age so-and-so, who did so-and-so. We're looking at just prevalence. And so here, the role of confidence intervals is not to detect whether a result is significantly different or not. The role of a confidence interval in this case is to do what? Is to tell us about what? This was from last class. In descriptive statistics, and you can type the answer too on the chat, what role does the confidence interval serve? It's a measure of what? Excellent. Pass the judge, excellent. It's a measure of precision. It's not a measure for us to make inference about the result is significantly different from the other. No, no, no. So that is so if you want to retire now and leave the class, you've learned, if that's the one thing you can take, that's awesome. So again, confidence intervals, when we're talking about descriptive statistics, and by descriptive statistics, I mean means and percentages, they are not to be used for like to make statements like, oh, it's significantly different, right? It's a different thing when we're now comparing, doing an eyeball test and saying we're comparing two things and say, oh, they overlap or do not overlap. But whenever you have a p-value or whenever you're making statements about comparisons, then you must be comparing two things. In this case, we're not comparing two things, and that's why the question in of itself is nonsensical. Again, for those who are lost as to what the question is, the question was, is the overall prevalence statistically significant? The only answer was that question is nonsensical. The question makes no sense whatsoever. All right. Now, we also said from last week that there are 3 phenomena that explain every single thing in the universe. We said it's truth, chance, or bias. Now, the second pop quiz is, sorry, let me put my phone on mute. When we use p-values, what are we controlling for of these 3 things? What do p-values control for? So again, we've established from last week that 3 things explain every single thing we see in the universe. It can be the truth, it could be chance, it could be bias. Why do we use p-values? What are we trying to control of those 3 things? You can drop your answers in the chat. Let's see. Okay, any dissent? Most people say chance. All right. And what do we control for with bias? We'll get into that, but how do we control bias? We want the truth, but the truth is not just hanging somewhere in space. The truth is, intermingled with bias and with chance. And so we said we have to control for bias and we have to control for chance. We control for chance by using p-values. How do we control for bias? So I can see a lot of answers here. Some say through research design, exactly. Some say through stratification, that's exactly. Some say randomization, that's awesome as well, right? Regression modeling, excellent. Those are all correct. Those are ways we control for bias. So again, the whole point of research, it doesn't matter whether your research is in social sciences or in epidemiology, is to find out the truth. But to get the truth, we have to control for chance and we have to control for bias. And so all the methodologies you learn about in grad school, from regression to propensity scores to p-values to e-values, is all about how do we quieten the effect of bias and the effect of chance so that we can get at the truth. So that's why we do research. So we're going to talk about chance today and understand p-values and how to interpret them properly. So here are some of the things that we're going to be, we don't want to assume knowledge. So there are some minimum knowledge foundations we have to establish to make sense, right, of this lecture. So we'll talk about hypothesis testing and p-values. We'll talk about univariate, bivariate, multivariate, and multivariable analysis, bias and validity. We'll talk about type 1 and type 2 error, and the role of sample size in all of this. All right, so I have another pop quiz for you. So this is a question on Quora. Do football players get confused by the whistles blown by the spectators during the game? Do you think this is a legitimate question? Why or why not? Let's hear your thoughts. We want somebody who is a strong football aficionado to tell us why this may or may not be legitimate. And you can unmute yourself and tell us. Lungile, can we have someone, please?
Yes, Ibrahim.
I think they do get confused. That's why a home advantage plays a role. The opponents keep disturbing with their whistle, and the players can lose concentration. Thank you.
All right, awesome. So now, if you're a player, right, you hear a sound, right, and you're like, okay, is that a whistle or is that just some sound? There are some questions you might want to ask yourself, like, okay, is that the referee's whistle? How do I know it's the referee's whistle? Or if it were not the referee's whistle, what are the chances it will be that loud? Or if it's the referee's whistle, what are the chances it will be that low? Of these 4 questions here, which do you think are the most relevant for the player? If you are the player, right? Which of these questions here are you most interested in getting an answer to? Ibrahim, you can continue, please, if your hand is still raised.
We have Albert.
Okay, Albert, continue there.
Okay, I want to talk on is that the referee's whistle? I think
okay.
when a game is about to start, the referee first blows his whistle for the players to identify how his whistle sounds. So when any whistle is blown in the crowd, the players are able to identify that it's not from the referee, but it's from the crowd.
Okay, thank you. Now, while at that point in time, right, of course, the whistle was blown 45 minutes ago or 60 minutes ago. Now you are the player, you're trying to make a decision. Your decision now is, should I stop play or should I just continue, right? Now, what will help you evaluate to make a decision? Like which of these questions here would make you come to an accurate decision or the closest decision you can? Sure, you are interested in, is that the referee's whistle? But you have to make that decision yourself, right? There's nobody to ask that question to. You are only there yourself to answer that question. So there's nobody to ask the person that, oh, is that the referee's whistle? So the act of deductive logic means that you'll have to ask yourself some questions, right? So sure, while question 1 is good, which other questions are more relevant to you making a decision? Maybe we can have someone else too.
Said?
Yes, sir. Good evening. I would want to go for, if it were not the referee's whistle, what are the chances it will be that loud?
Excellent. Why do you think that is a reasonable decision?
Yes, because I will want to be sure they say it's better to err on the side of caution. So I want to go for, if it is not, then it is.
Okay. So let's marry that your answer with the original answer given by the last respondent. They said the referee blows the whistle at the beginning so that everybody's calibrated and they know what the referee's whistle sounds like. And then in the middle of a game, while you're just about to score, you hear this whistle from somewhere, and you're like, okay, if it were not the referee's whistle, what are the chances it will be that loud? And you conclude that the chances are very, very low, that there's no way a whistle from someone in the audience will be that loud, right? So that the chances are very low because, you know, regular whistles are not that powerful. So based on that, you decide to do what?
I will ignore the whistle.
All right, so you say that you hear a whistle sounded, right? And the whistle means stop the game. And you're like, is that a whistle from the referee, or is that from from someone in the crowd? And you have to make an analysis within yourself, and you ask yourself, if it were somebody from the audience, what are the chances that the whistle will be that loud? And you conclude that, well, the chances are very low. So if the chances are very low that it's somebody from the audience, the only conclusion is that it is the referee's whistle. That's how you make decision. Does someone have another take on this? Emmanuel, I see your hand is up. Emmanuel Andrew.
Okay, good evening. Can you hear me?
Yeah, we can hear you clearly, yes.
Okay, so I just want to support the answers you gave. So if I were to be in that position, I will employ the assistance of the linesmen who are assisting the referee. So that will tell me whether it is a decision that was made by the referee or not.
Okay, all right. Let's draw it down to statistical terms, right? So we are always trying to compare two things, right? In this case, we're trying to compare, is that noise or is that a signal, right? And then the role of chance comes in here because we're like, what are the chances? So if you look here, right, the key words here are the words if and the word chances, right? If is a very, very powerful word because it lets us know that this is all about conditional probabilities, right? It's like, okay, if this were not the referee, what's the chances that the whistle will be that loud? We know that referees have special whistles that sound very, very loud. So I'm not going to take a chance and get a red card. I'm just going to stop because I don't think that the referee from somebody in the crowd will be that loud. That's a decision that goes on in your mind, and that's how you make a decision. So at any given point in time, you have to make a comparison between two things. Is this a signal or is this noise, right? And this is why we said this original answer was nonsensical. There is nothing you're comparing here. You're just saying, the question is, what is overall prevalence? There's nothing to be compared. When we make statistical tests, we are always comparing two things. Is it noise or is it signal? Is it the crowd or is it the referee, right? That's what testing involves. We're trying to compare two things and make a decision. Again, remember, the whole point is not just to compare for comparing's sake. We're comparing to make a decision, all right? Let's go to another example. By the way, the use of any, religious text here is purely for instructional purposes. Now, in scripture, there is this analogy that if the horn sounds an indistinct sound, who will get ready for battle? So now you are the guy who has been asked to mount the tower and look for enemies who are approaching. And your task is simple. You only have one job. When you see enemies approaching, you're supposed to blow the horn. And you're supposed to blow the horn really, really loud so that the guys who are in the city will hear it clearly and will come out. Now, let's say you are just about to have dinner in your house and you hear this sound that tells you that, enemies might be approaching, right? But you're not very clear because the horn doesn't sound very well. What are some of the things that might go through your mind? Like, imagine, you're right there about to eat dinner and you hear a sound that sounds indistinct. What are questions that you might ask yourself, and how could you come to a decision? Any takers?
Adams.
All right, good afternoon, everyone. Yes,
Hello.
in the first instance, I must be able to distinguish between the sound of the particular trumpet and the other sound. I must have the differences. If I can reach a conclusion.
Thanks. And what are some of the background noises that could be confused with? Because your job is to make a distinction between that horn and all the other background noises. Remember, we are always comparing two things. In this case, you're comparing the sound of a horn with the sound of what exactly? Okay, maybe we've lost Adams. Anybody else want?
Okay, Yahaya.
Good evening. It's evening here.
Hello.
And for me, so I would say, is this sound from the trumpet guy, or is it a cow that is mooing?
Exactly.
So, and if it is from the trumpet guy, what am I supposed to do? Am I now supposed to get ready for battle? Or,
exactly.
Yeah, thank you.
So it could be sound, it could be the cows mowing in the background, it could be the children playing, it could just be background noise, right? So the question is this sound I'm hearing, is it truly the sound from this guy, or is it just some background noise, right? And remember that the whole point of doing statistical testing is not just to have an intellectual discussion, it is to take action. If I decide that this is just the guys playing, well, the decision is to continue with my meal, right? If I, however, decide or determine that this sound is from this military guy, well, I have to go out and fight, right? That's not the time for me to sit down and start, continuing with dinner because lives are at stake. So the point is we're trying to establish so far is that when we talk about statistical testing, we are always comparing two things. We are saying that we're comparing, is this a noise or is this a signal, right? And so our job is now to make an evaluation and say, if this were just some noise, what are the chances it will sound so loud? This is something this is our evaluation to make every day in our lives, right? We're like, okay, the car behind me, is that a cop? Okay, if it were a cop, won't they have some more dramatic appearance? Or, we always make these evaluations every day in our life when we're trying to compare some signal versus from some noise. And that's the whole basis of statistical testing. That's what we do. Now, in this case, right, it's possible that you can make a mistake, right? Because remember, you have to make an evaluation, you have to make a decision. What are the two mistakes you could make in this whole process? And how do you decide to manage the risks from either one of them? How do you decide which is a better mistake to make?
Amina?
Thank you very much, Prof. One of the mistakes you can make is deciding it is just an index is just a noise, and then sitting down just to find out that it was actually the trumpet for the battle. Or
exactly.
The other side is you can decide it is the trumpet, prepare for battle, go out, and then find out it is just a noise. So if you're looking for the safer option, it's better you still go out, whether it's the trumpet, then find out that no, it's not, then you can come back and have your dinner. If it's the other way around, the risk is higher. Thank you.
Exactly. And so you always, and now the point is that the consequences vary from circumstance to circumstance. In this particular circumstance, it's like, oh, okay, if it was a trumpet, but you decided that it was just the kids outside playing, well, before you know what, the Roman armies will come and kill you right there in your house, right? And that's the end of it. So it's a safer bet for you to say, well, I'm just going to err on the side of caution and just go and check it out, right? And so that's the whole idea behind what we call type 1 and type 2 errors, right? I always talk about the story of the boy who cried wolf. That's a way for us to remember type 1 and type 2 errors. If you've attended our classes, you should know the story in and out. Who has attended a previous class of ours that can tell us the story? What's the story about this boy who cried wolf? And how does it help us illustrate the lessons for type 1 and type 2 error? Who wants to tell us that story? It's just a very short story of 30 seconds. Any takers?
Pat?
Okay. Oh, thank you. I think the story is about this young boy. Every day he will cry, wolf, wolf, and the villagers will come out with clubs to kill the wolf, and they'll find no wolf. So on this particular day, he cried, a real wolf came. He cried, wolf, wolf, and everybody thought he was joking as he used to joke, and nobody came out, and the wolf devoured him.
Excellent. So what was the first error the villagers made in this story?
They did not go out to check whether the boy was serious or not.
No, the first error, the first one.
They did not reprimand the boy each
Okay.
time he was joking.
Okay. Or we can say that they went out when there was no wolf. Is that a correct statement too? Yeah, so the first error was going out when there was no wolf. What was the second mistake they made? Oh, we've lost her. All right. Anybody else? What was the second mistake the villagers made?
Francis?
Yes, the second mistake was that the day that the wolf actually came and then attacked the boy, they thought that was his usual theatrics. So they did not go out to rescue the boy, and that's the type 2 error they made.
Exactly. So type 1 error is exactly that same way. We go out when there is nothing. We say, oh, our result is significant. Here's the p-value. Wow, look at the evidence we have. We rush out to say we have found the goal, the cure to cancer with whatever the result we have, right? But there's no wolf. There's no real result there. All we're just finding is just noise. Type 2 error is the opposite. When we are supposed to go out, we say, oh, well, our results are not significant. But are you sure? Are you sure the results were not significant? Or is it just that you did not find significance when one existed? So those are two different things. And it's helpful to understand why we call them type 1 and type 2 errors, right? They're called 1 and 2 because that aligns with the Greek alphabet. The first letter in the Greek alphabet is alpha. The second letter is beta, right? So that's why we call them type 1 and type 2, because type 1 is, when we, type 1 is also called the alpha error, or beta is, when we, find something when it does not exist, right? Which is type 1, or type 2 is when we fail to find something when, it exists. You can also remember type 1 and type 2 error because type 1 error has only one word in it, which is reject, right? Type 2 error is fail reject. So we reject the null when we should not have. And we'll talk about the null in a minute. So let's not go ahead of ourselves. So just know that it's type 1 and type 2 error to correspond with the first and second letters of the Greek alphabet. Now, one of the things we also need to understand to make up the puzzle of statistical inference is the concept of hypothesis testing and null, as well as alternative hypothesis. The null hypothesis, as the name implies, means nothing interesting is happening here. Like nothing is happening, right? At least nothing interesting is happening. The alternative is, well, something interesting is happening. That's how I want to remember it. So I have an pop quiz for you. In life, do we perform things under the assumption of a null, or do we perform things under the assumption of the alternative hypothesis? Think of just general things in life. When you do anything you're doing, right? Is it performed under the null or under the alternative? So let's say and remember that the null says nothing interesting is happening. The alternative says something interesting is happening. So who wants to give us a try? So let's give a practical example. When you set an alarm to wake up in the morning tomorrow, is that activity done under the null or under the alternative?
Okay. I also want to read out some responses from YouTube. I've been missing their responses. You can please respond again. I'm sorry I missed your responses earlier. For now, I'll just continue here on Zoom until there's something on the chat box on YouTube. Chiawa. Chiawa, you can unmute yourself. Oops.
Thank you, Prof, for the wonderful lecture. I believe that most things in life are done based on alternative hypotheses, because the interest to go about things in the first place, we want to find something, we want to believe that something is happening, we want to pursue, we want to have, there's a motivation for doing things. So I believe that most things are done with the assumption that something interesting is occurring. Thank you.
Okay, please let me, while you have you on the line, let's investigate that further, right? When you go out to, let's say driving the car, you want to go to get groceries or go somewhere. When you put on the knob of your car or the engine, what do you expect? Do you expect that something out of the ordinary will happen, or do you expect that nothing out of the ordinary will happen? Because we need to understand this concept to really understand statistical testing. We need to understand whether life occurs under the null or under the alternative. And if we've lost him, does somebody else want to pick up that argument? When you set an alarm, say, okay, I'm going to wake up tomorrow by 8 a.m. Is that activity being done under the null or under the alternative?
Okay, from YouTube, they say alternative hypothesis. Let's hear Agada.
Okay, thank you, Prof. Thank you. That activity is being done under the alternative because I hope to wake up tomorrow morning. So I'm optimistic that I'll wake up, and that was the reason I put on the alarm. Thank you.
Okay, awesome. Now stay on the line. If you say that you hope to wake up tomorrow, is that assumption under the null then, or is it under the alternative? Remember, the null says nothing out of the ordinary will happen. Alternative says something out of the ordinary will happen. When the act of waking up, is that something out of the ordinary, or is it just out of the ordinary?
Chiawa?
All right, so I think I understand what Prof means now. Initially, I think I misconstrued it. So if null hypothesis is saying that nothing out of the ordinary, then it means that most things are done because they are predictive. Like, you know that this ought to happen. So most things are done on the basis of null hypothesis. That ability to predict what will happen is usually the reason why people go on to do.
Exactly. And think of anything in life. When you go to sit on a chair, where you're not looking at the chair, right? You are hoping, you don't expect that somebody will take the chair out from under you. And that would be ridiculous, right? When you set an alarm, you expect that, well, you're going to wake up. When you're traveling and you're like, okay, I'm going to meet you in 5 minutes. I'm going to drive. You don't expect that you are going to have your car is going to break down, which is something out of the ordinary. You expect that once you put in your key in the ignition, the car will come on. That nothing out of the ordinary will happen, right? And why do you expect that? Well, because I expect that if I set up my alarm, I'll wake up tomorrow, because for all the past years of my life, I have been setting the alarm and waking up the next day, right? So the probability is very, very small that something out of the ordinary will happen. That is why I have the confidence to say, well, today I'm still going to set this alarm under the null, because there's evidence, the chance that it will happen that the alternative will happen is very, very, very small, right? So that is, we need to understand all of that premise to understand how, because life itself is a test. The test is, will I wake up tomorrow? Will there be significant difference between today and yesterday, right? That is what we're doing in effect when we set an alarm. You are setting up a hypothesis under the null that nothing out of the ordinary will happen. So that's the exact same thing we do with statistical tests, right? This is why we test under the null, right? Again, we go back to the example of the football players and the referee. The player, he has heard this is not his first time in the rodeo. He has been to 1,000 matches. He knows what the normal crowd sounds like. So when he hears a very shrill whistle, it's like, is this part of the ordinary or is it out of the ordinary? Well, if it's part of the ordinary, that sounds like just the crowd he has heard 1,000 times. So he has to make up and say, no, the chances that this is part of the ordinary is very little because this sounds much louder than the ordinary. So this means that it is likely that this is from the referee, or it is very unlikely that this is from the crowd. So I have to stop. These are the decisions, but the fact is that we make these decisions in split seconds. So we don't really pause to stop and analyze them like, bit by bit. But that's the decision making we go through every time. It is the exact same thing with statistical testing. So when we come up with a p-value that is very small, this is the player saying that I think that the chances or the probability that this is coming from the crowd is very, very, very small, which makes me to conclude that this is out of the ordinary. That this can't come from the crowd because the chances are just too small. I think it's the referee, so I have to stop the game. So the moral of the story is that we do statistical testing to make decisions. It is all about making decisions, right? And to do that, we have to look at chances and make decisions and hope that they're the right decisions, right? But also knowing that it's possible that we could commit a type 1 error, a type 2 error, and we pray and hope that we go for the lesser of two evils. We hope to get the truth, but if we are wrong, we want to make sure that we fall in the lesser of two evils. Now, you also know that this is the same thing, calibration occurs with lie detectors. When you take a lie detector, at least if you watch the movies, they don't just go and ask you, oh, did you steal that money? No. They first of all ask you some calibration questions to see how your response works under the null. Because again, everything in life takes place under the null. So they ask you, okay, is your name so-and-so? You say yes. They observe the record and like, okay, this is how he responds under the null. Then they ask you, are you sitting in a room and are you wearing a red shirt? You're like, yeah. Again, the response should, establishes your baseline or your null. And then they ask you, oh, did you steal that money? And you're like, no, I did not. Like the whole thing goes very, very, very spiked. And your response is quite different from what occurred under the null. And they're like, oh, you're lying because your answer under that question is quite different from under the null. So the question is, what are the chances that we will have gotten that kind of erratic answer if you were not lying? Well, the chances are very, very, very small. So we conclude that you're lying, right? So again, everything we do is under the null, and this is the exact idea behind p-values, right? That's why we have the word if in probability, right? The player asks himself, if this was not the referee's whistle, like what are the chances it to be that loud? So if you're talking about p-values and you have not used the word if, you have not completed the explanation, because the idea is that if indeed this was under the null, what are the probabilities, what are the chances that I will see what I am seeing right now, right? And so you say, okay, the chances are very, very small, and that's how you make a decision. All right. And now one of the misconceptions with p-values is that it's stuck in stone. Like you have this p less than 0.05, which you must use, right? P-values are not another lesson one really establishes that they're not set in stone. You can determine your p-value for your study and say, okay, I am willing to go with this p-value, right? Because remember, p-value is also the alpha threshold. And remember, alpha is the chances that, who can remind us of what the alpha is? Alpha level. Remember, we said alpha is the first letter of the Greek letter, and Greek and beta is the second letter. So what does alpha represent again? Who can remind us so that we're all on the same page? Let's go back there, alpha. So let's look at it from first principles, right? when you say somebody, have you heard of a term like an alpha dog or an alpha man or an alpha female? What do people mean when they say that? When you hear of a term alpha male or alpha female or alpha dog, what does it mean? Or in what context do people usually use those terms? What kind of person is usually described as alpha? Because we need to understand that to understand alpha error or, alpha levels or type 1 error. Who wants to answer?
Charles? Okay. Mikhail?
Okay. If that person is your first one, or let's say that dog is your first dog, you can say alpha. You
Okay.
have been that for the first time, you can say alpha. We use in this kind of situations more of the time.
Okay. But, in what other context do people use the word alpha? And sometimes in a somewhat negative context, or at least somewhat negative context, when they say, oh, this alpha, like in general, like what context do people use the word alpha?
From the chat, it's usually used to describe a strong man or woman. Someone says it's synonymous to the beginning, God, 95% confidence, dominant character,
Okay.
type 1 error, first, reject. Yeah.
Okay.
The
We're
beginning.
just sticking with the English meaning, just the general meaning now, not statistics, right? So let's go with that definition that says dominant, or can somebody just check the, urban dictionary? Let me check urban dictionary. Let's see what, but urban dictionary sometimes has very sketchy definitions. But all of those are correct. Like, let's see, urban dictionary. All right, alpha.
Starting point.
All right, so let me look for an answer that is a bit appropriate, because this type, the urban dictionary sometimes goes wild. All right, let's just go with this safe answer. The head animal in the pack, and by extension, an unofficial leader, right? That's what, how urban dictionary defines it. Now, what is one characteristic of an alpha male or alpha female? Are they usually reserved, or are they usually in your face, or just out there? Like, what do you think? Based on what we saw in urban dictionary, how will you characterize an alpha person? Are they reserved, or are they just dashing in and rushing into set scenarios?
Simone. Oh, your hand is lowered. Okay. Papula. Papula?
Okay. Alpha means domineering, sort of.
Okay.
Domineering.
So, do you think a person who's alpha will find themselves in more trouble or in less trouble? What do you think?
In more trouble. In more trouble.
Why do you think they will find themselves in more trouble?
Yes, because they think their opinion is always right, and probably so that's why they always want to dominate or something like that.
Exactly. And it's also big that, okay,
they
sorry,
feel
go ahead.
stronger than any other person they are dealing with.
Exactly. Right. And also they might think that they know it all, right? So they
Yes.
hear something and they just dash in. Oh, today is crypto. All right, I'm just going to take out my money and invest. Tomorrow is this, right? Like, all right, how about just sit down and think about it a bit more carefully, right? So the point is that the alpha dashes into things, and they are going to make some errors. There's going to be a lot of false positives in how they do things. So that's the whole point of alpha level. So when we set an alpha level, it's like, all right, Mr. Alpha, here is the level on that we know you like to rush into things and come up with a lot of false positive results, but this is the level of comfort we are comfortable with, right? So when we say a p-value of alpha level of 0.05 as significance, we understand that this Mr. Alpha likes rushing into problems, right? And we're saying that we are comfortable with 5% error rate, like, Mr. Dude, you like getting into trouble, right? The only thing we are comfortable with is 5% error rate. That's all. Nothing more than that, right? So when you set an alpha level, what you're doing is you're saying that this is the level of false positives that I am willing to accept from this alpha guy, right? Remember, this alpha guy just rushes into things, comes back, oh man, I lost all my money in this, I didn't think about it, upfront very well. Now I'm broke. And tomorrow is a different story. It's like, why don't you just calm down a bit, right? So when we set a p-value or an alpha level, we are saying that this is the level of error we are comfortable with. So a 1% error rate means that we are willing to say that if our results came up, if this alpha guy came back with results, we are willing to say 1 out of 100 of them is wrong. Like, he came back and say, oh, I've been successful. Like, oh, really? We've heard this story before. Let us now examine what you call a success, and let's see how many of them were truly successful, right? So with a 1% error rate, we're saying that if he claimed that 100 things were successful, actually one of them was not successful. If we have an error rate of 5% or p-value of 0.05 as our level of significance, we are saying that we're willing to accept the 5% error rate. So in other words, it means that if we run a clinical trial and we say we helped or we saved 100 people, we're actually willing to say 5 of them were actually not saved, right? Because they are false positives. If we're accepting an error rate of 10% alpha, remember the alpha guy loves to rush into things, right? We're saying, okay, we can only accept 10% error rates, right? So it means that we are willing to be, we have assigned ourselves and, accepted the fact that, well, 10 out of 100 positive results may actually not be positive. Maybe just be 10 of them may be false positives, and the other 90 are true positives. So at the end of the day, it boils down to how sensitive is the issue we're talking about, right? If it's an issue of life and death, do you want to set a high alpha level, which is your level of comfort with, with error, or do you want to set a low alpha? What do you think? Who wants to give us their opinion? It's a life and death scenario. Do you want a big alpha or a small alpha?
Prof. Landry.
Low alpha.
Excellent. You want a low alpha, right? Because let's say you are like, very, very, sensitive issue, life and death, let's say drug for cancer. You don't want to say, oh, we cured 90 people, we cured 100 people, but 10 of them were actually, not cured. It's just false positive results. Now, on the other hand, if it's just something that is not that sensitive, let's say we're just doing an educational intervention, and the stakes are not high. Even if our statements were wrong, well, nobody dies, right? We can then accept a higher level of alpha, right? But the point we're trying to make is that your level of alpha is not stuck in stone. It's not a 11th commandment from God that your p-value of your alpha level of significance must be 0.05. It's all about understanding the context in which you're operating and saying, okay, we're going to go with this level of alpha or no, right? So it is important to know what affects, alpha and what affects beta. Beta is when, when you say if somebody is a beta, what does that mean? We need to understand this from just the colloquial use of the term. Have you ever heard somebody being described as beta? What does that typically mean? We'll talk about alpha, right? Alpha is outwardly going and just a go-getter in your face all the time. What about beta? What's the typical context in which people you describe someone as a beta?
Desalaine. Henry.
Okay, it simply means small.
Okay. Small or lesser version is the very opposite of alpha. So beta is why alpha is going out there and killing it. What do you think beta is doing? We know that we've established that alpha is out there killing it right in your face. Where do you think beta is at that moment?
Rita from YouTube says beta man doesn't take the lead. Let's hear Ibrahim.
Yeah, I think it's someone that is timid, submissive, easily manipulated.
Excellent. So beta means that, so when we say beta error, or it means that, so type 1 error is going out there, getting results that are not, even the ones that are not significant, and saying, oh, they're all significant because they are brash. Type beta or type 2 error is the very opposite. Even when it's significant, when you say somebody is timid, they can't stand up for themselves. They can't defend themselves. So even when the study is significant, it says, oh, I'm shy, I'm not significant, right? That's what beta error means. Like, the results are significant, but it refuses to show significance because it's timid, it's shy, right? What's the number one cause for type 2 error or beta? Why is it so shy? What causes type 2 error the most? What's the most common cause of type 2 error?
Ibrahim.
I think being over-inclusive.
Okay. Somebody define beta as small. Small what in this context?
Sorry, Prof. Someone from YouTube said beta is the probability of accepting the null hypothesis when it is false.
Okay. Thank you. But now in this context, right, what is this? We said a beta person is shy, and like we said, okay, you have a beta error when your study is shy. So even when it's significant, it says, oh, I'm not significant, I'm shy, right? Now, the question we're trying to establish now is, what is the most common cause for type 2 error? Or why is the study suddenly beta? Why is it feeling so shy? Because it has a small what?
A lot of sample size on the
Exactly.
chat box.
Sample size. So the most common reason for a type 2 error is underpowered studies, right? Studies that have sample size that is not sufficient. Remember that we define power. Statistical power is 1 minus beta, right? So 1 minus beta is power. So when we talk about the power of a study, your power is study is powerful, is the opposite of beta. It's like 1 minus, because 1 minus beta equals the power. So if your power is 90, that means your beta is 10. If your power is 80, that means your beta is 20. Right? So that's the relationship between the power of a study and type 2 error. So your study is shy and it's hiding in the shadows because it doesn't have the confidence to come out because it has a small sample size. And so it ends up saying, oh, we're not significant, even though the study was significant. You just did not have a sample size to detect the differences that existed. So we need to understand what causes that. And this is pretty common. This is a study in the BMJ that showed that of, over, 66% of high impact factor, clinical trials published in some of the top journals did not calculate sample size correctly, right? So that is a very shocking statistic. So we have to make sure that we design our studies correctly and that we account for sample size so that we avoid type 2 error. Now, on the other hand, what's the most common reason for type 1 error? Remember, type 1 error is alpha. And we said alpha is the guy going out there and bringing fake results that don't even exist. Why does he do that? Under what context do we get that kind of behavior?
Charles? Charles, there's no sound. But on the chat box, there's biased researcher.
Okay. Biased researcher. All right. But what else, right? How do people find p-values? Let's look at it this way. You've heard of people looking for p-values, right? And saying, no, our results are significant. How do they end up getting those results that are significant from your experiences? How do people come up with results? People who are desperate to publish and who just want to show a p-value as significant, how do they go about doing this? Because that is what we're talking about. That's type 1 error.
Christopher.
I think when the alpha, when there's a too high significant level, for example, instead of using 0.05, one side to use 0.10. That will also cause
Thank you. Okay, that's one way. What other ways do people get results when people come out and proclaim that, oh, our results are significant? People who are so desperate about p-values. What ways do you think they go about getting this p-value that they come and publish?
I think they manipulate or falsify.
Okay, how exactly?
Passy?
Think it's multiple testing analysis give us keep going on an expedition to fish for something.
Okay, thank you. Those are very excellent words. We want somebody to elaborate on them. He said that they there's a lot of background noise. He said they multiple testing, and I see somebody, Charles, thank you very much for your comments on the chat. It says desperately hunting p-values, right? So it's like, okay, I want to compare these two groups and that group. Okay, the result is not significant. Now I'm going to compare this and that. And then I'm going to compare the remaining 1 million groups, right? And I'm going to do this until I get a result that is significant. We call that p-hacking, right? You have turned research into a fishing expedition. This is not good, right? So that is the number one reason for type 1 error. Remember, type 1 error or alpha, you're just going out there and bringing all these fake results that don't exist and telling us that they're significant. And the way you do that is just by indiscriminate comparison of groups all over the place, indiscriminate subgroup analysis. Those are ways that people use to generate results that are not consistent with the evidence. All right, so the issue of sample size is very important, obviously, because we want to get results that reflect the reality. We want to get the whole truth, right? And so one of the emphasis we're going to cover next week is on the aspects of multivariable analysis, on how we can make sense of them. But this is just to give you a primer of what that means, and also give you some reading material ahead of next week. One of the things we also want to do, obviously, is to answer or complete some of the sections that we did not cover last week, which was about data visualization and how to interpret them. So we're going to pause the material for today here, because today's session was purely about p-values and how to make sense of them. Next week, we're going to focus largely on interpreting results from regression analysis and other aspects of inferential data. But I want to see if there are any questions you have here so far before we go ahead and really focus on this part. So now that we know that the most common reason for type 2 error is small sample sizes, how do we make sure that we don't fall prey to that? And how do we also prevent falling prey to type 1 error? That's what we're going to discuss for the rest of this session that we have. But I just want to pause here and see if there are some burning questions that you have that we can accommodate quickly. I'm going to take just like 3 or 4, and then we'll go on to the next part of the class, if there are any questions.
Charles? Charles, unfortunately, we cannot hear you.
Okay. How about now? Hello? Hello, can you hear me now?
Yes.
Okay, sorry. One sensor was on my phone because my laptop is off. Okay, so Prof, I'm just trying to, it's more or less like a comment from what you said the last time. I think one way to avoid type 1 error or to force people to avoid it is to ensure that they ab initio, before they research, that they develop their SAP, their statistical analytical protocol, which will show what exactly you want to do, what exactly you want to analyze. Not that at the end of the day, because you're just looking for something to report, you will just be analyzing anything and project. So I think that's one way. That's what I wanted to say. Thank you.
Excellent. Yeah, thank you very much. All right, so we're going to take 3 questions, 3 burning questions. If they're not burning questions, they can wait. After the class, we'll answer the rest of the questions. But do you have a burning question you want to ask? You can drop it on the chat, or you can raise up your hand and ask that. And then we'll look at.
Is it necessary to have a p-value for every research?
No, it's not necessary to have a p-value. In fact, your study doesn't have to be, inferential at all. If you go back to at the very beginning, let me go back to the homepage. Oops. Remember the very first slide we had, the study we looked at last week? Well, it's just descriptive analysis, just looking at the prevalence of. So you see there are no p-values here. We're just saying the burden of smoking is high because 1 out of every 5 Americans smoke. That's a big problem. It is not until we don't need a p-value to come and bless our lives before we pass out meaningful messages. So no, you don't. It's not a requirement that your study must have a p-value, right? So so the whole body of descriptive analysis is not really focused on p-values per se. It's when we get to analytical studies that we now start to worry about. Okay, remember that the whole premise is that this is. Let's go back here. We want to find the truth. I want to quieten the impact of chance and bias, right? So when we come to the world of analytical epidemiology and we're comparing things, that's when it becomes more important to do all of that. But for descriptive analysis, no, we don't. And so let's really grow out of a mindset of being too worried about p-values. Life is much bigger than p-values, right? We obviously need to understand what it means. We need to know how to use it properly. We need to know when to use it. We need to know when to use different thresholds for alpha, and when it doesn't really matter so much. So in the whole scientific community, there's actually especially in epidemiology, a gradual distancing away from p-values, because the problem is that p-values have been hijacked by people who have very little knowledge of what p-values are, and to them, the world begins and ends by p-values. And it's like, no, that's not how we do research, or that's not why we do research. And how do we focus on issues of public health relevance or clinical relevance? Of course, p-values are useful. I'm a big supporter of p-values, and that we shouldn't abolish them altogether, but we need to train people how to use them reasonably well and how to understand what they mean in the first place. Okay, next question, please.
Dr. Onyime.
Okay, thank you. Thank you, Prof, for your lecture. Very interesting. At the beginning of this class, you said for you can use p-values, they must compare 2 things. So, but sometimes we use p-values in assessing association between if something is associated with another thing. So, but that's not comparative. So I don't really understand when you said
okay, give me an example. All right, let's take your example, right? So you're saying that your example is you're trying to look at association between 2 things, right? So
I didn't hear you.
So the example you said that p-values sometimes may not be relevant when we're comparing 2 things. Then you give the example like you are looking at an association between 2 things. So let's interrogate that statement. What 2 things are you looking at the association between?
Okay, I can say it's association between maybe gender and knowledge.
So gender and knowledge. And you are saying, is there an association between gender and knowledge? right?
Yes.
Now, for gender, what are you comparing with? What are things you are looking at? Who are you comparing with?
Okay, and I get you, male and female. I understand you.
So you're comparing male and females. You can't just say,
okay.
I'm looking at males. It's like, that makes no sense. Whenever you have a p-value, and this is why one of the things we're going to cover next week is the wrong use of language in reporting findings. And we're going to cover this more next week. But just to preempt it, look at statements like this. It says that, let's see, let me find the exact place that I want us to. Okay, factors that were associated with malaria AKI death included acidosis with an adjusted odds ratio of this, and KDIGO stage 3. Okay, that is not a very useful statement. It's like, what is a comparison? You know, when you say factors where acidosis, like that is not a very meaningful statement at all. Are you saying we're comparing individuals with low acidosis versus high acidosis? Are you saying we're comparing? So for many reasons, that language is just not helpful at all. If you have a p-value, a p-value means we're comparing two things. And we're going to go a lot more into details on that next week. We're going to talk about regression and what regression is in the first place from fundamental principles, right? But the point is, if you have a p-value, you're comparing two things. If you're not comparing two or more things and you have a p-value, well, something is wrong because the result is nonsensical. I hope that makes sense. And that's why my original question was nonsensical. When I asked you here, what is the overall prevalence statistically significance? That question does not make any sense because we're just looking at overall prevalence, one number. We're not comparing to anything else. So you can't talk about whether the result is significant here because it doesn't just make any sense. All right, next question.
I'm asking if it's fine to have alternative hypotheses in the work, but when we test to change them in null hypothesis, then report value in alternative way, just accepting hypothesis.
Okay, so the point here is that we always test against the null, right? Because life always occurs against the null. You know, let's say you have a pharmaceutical company, you've developed drug A, right? There's what you hope. You hope that your drug works good, drug A. So the null is that drug A sucks. Obviously, we don't use this term, but I'm taking huge liberties here. The alternative is that drug A rocks, right? Of course, this is what you want to demonstrate. Like, there's no way we're going to allow you to say, just come and prove what you want so you can go and make money, right? No. We are going to set your study against the null, and it is your responsibility to prove that the null is wrong, right? We can't just say, oh, okay, obviously you want to prove to the world, you want us to believe that drug A rocks. But first of all, you have to prove that it does not suck, right? This is why we test against the null. Otherwise, what's the whole point of research? People will just come and say, oh, yeah, the alternative is, this is the alternative. That's not even research anymore. That's just you coming to declare something, right? That's what a king will do. A king will come and declare that this is law. That's not research. Research is investigative. So we have to set it against the null. The null is that nothing interesting is happening. If your drug works and cures cancer or ends, HIV, wow, that's something extraordinary. What is ordinary is that your drug does not work, right? Again, remember, life occurs in the null. So we have to test against the null. Now, if we now see a result that is so amazing, we now have to say, if indeed this drug sucks, would we see this kind of result we saw? Well, remember, that's the whole premise of hypothesis testing. We set against the null, right? We say, okay, we are going to test you against the null. And then we see the test results, and the results is like, wow, like just over the top. And we now say, if indeed the null were true, what are the chances that we'll have seen this kind of massive result we just saw? The chances are very, very, very low. It's like saying, if this whistle was from the crowd, what are the chances that it will be this loud? Well, the chances are very, very low. So we then have to conclude that, well, this is not from the crowd. This is indeed from a referee, right? That is the whole process through which we investigate hypotheses. But we can't just come out from the very start and say, hey guys, just accept that this drug rocks. Like, no. How? Why? We have no basis to believe you. Proof, first of all, that the drug doesn't work. We have to believe the null, then believe you. And then, if indeed your results are so extraordinary, beyond what we'll expect if the null were true, then we'll believe that, well, in this case, we'll disregard the null and go with your claims. I hope that answers your question.
Does the standard error take...
Sorry, go ahead.
Does the standard error take to value of p-value?
Does the standard error take to value? Sorry, can you repeat that part?
Yeah, does the standard error take to value of p-value? Halima, if you can just rephrase your question so it can be clearer.
Okay, I'm going to answer the question in an indirect way. So the question is that what's the relationship between the standard error and the p-value? That's how I choose to interpret the question. So next week, one of the things we're going to learn is that very thing. What is the relationship between standard error and the p-value? Now, some of you, when I asked this question, that why is the question nonsensical, some of you said, oh, because there's no p-value. But if you have a confidence interval, you can actually calculate the p-value, right? That's why that question, so the overall point here is that the question did not make sense. But you should be able to calculate p-values from confidence intervals. You should also be able to calculate p-values from standard error. So if you give me the standard error, of course, I'm going to give you a p-value. If you give me the confidence interval, of course, I'm going to give you a p-value, right? And that's why, in general, would prefer you reporting confidence intervals. Because if you gave me the odds ratios with the confidence intervals, oh, I can do a lot of things with that confidence interval. I can give you the exact p-value. I can know how precise the estimate is. I can tell you so many things that I could tell you if than if you are just giving me a p-value only. So, but we're going to cover all of those things next week in terms of how do you interpret p-values, how do you interpret, well, we'll cover p-values today, but how do you interpret things like, odds ratios and confidence intervals, and how does that relate to, standard errors and things of that nature? That's part of our curriculum for next week. All right, I'm going to take one last question, and then we'll go to the demo for issues of sample size so that we are all aware of how we can take better precautions when we are estimating sample size for both descriptive studies as well as analytical studies. So one last question now. The rest of the questions, I can take them afterwards.
There are plenty, shame. Moses.
Okay, good evening. For me, it wasn't clear how you determine the power of your test. How do I know that my power is 80%?
You decide that it's 80%. And we're going to do that in the demo, right? So, but remember, power is equal to 1 minus what? This is a pop quiz. Very good. So 1 minus beta gives you power. So beta means, remember, your beta is the one hiding in the shadows, very shy and very scared. And so power means 1 minus beta. So we need to understand that. So the moral of today's class is wherever you have a p-value, you are comparing two or more things. You cannot compare one single estimate by itself. That makes no sense. That's nonsensical, right? We've also established that, what alpha is, what beta is. Alpha is the first letter of the Greek alphabet. Beta is the second. That's why we call them type 1 and type 2 errors, respectively. We've talked about the most common reasons for type 1 error, which is when you turn your study into a fishing expedition, and the most common reasons for type 2, which is when you have underpowered study. And you see underpowered studies everywhere, right? All right, so let's see how we can address those things with how we conduct our study. So we're going to look at sample size calculation and see what kind of considerations we need, how we decide levels of beta and alpha, and how all of those things come into play. So let's go to sample size, and let's select sample size. So remember that the considerations for sample size calculation for a descriptive study are quite different from those when we have an analytical study. Analytical studies are studies where we are comparing two things, right? Descriptive, just we don't have two things we're comparing per se. The purpose of descriptive studies is to quantify the burden of an outcome in a population and see how it varies by characteristics of a population. So when we're calculating sample size for descriptive studies, the main thing we're worrying about is precision. Precision is a major thing we worry about when we calculate sample size. And we're going to use the Chisquares platform to do that. For those of you who do not have access to the platform, we'll share the link with you so that you can access it and practice. You got to go and practice after the class today so that you can, because practice makes good. All right. So let's start with the descriptive study. So we're going to just do two sample size calculations, one for a descriptive study and one for an analytical study. And we'll look at some of the things we need to pay attention to when we're calculating. So let's say we're doing a survey, which is a descriptive study, and we want to pay attention to sample size issues. Let's see some of the things and how some of the things we've discussed apply in this case. So we'll go to cross-sectional study, we'll select percentage as outcome. And remember, we said when calculating sample size for a survey or a cross-sectional study, our major concern is about precision. Remember, precision is how wide or how narrow our confidence intervals are, right? Now, the most important thing here you want to worry about is this number here called the margin of error. The margin of error is half the width of the confidence interval. And if you're not sure of what those terms mean, we've provided hints here that tell you what they are really, right? You don't want to go and spend money, conduct a study, and then you find that, the sample size was too small, and so your confidence intervals are very wide. And you're like, oh, if only I had known. Well, you could have known before. It's not a secret. There's no secret about that, So this is the point now. Now I'm telling you, so you won't say, I didn't know, right? So margin of error tells us what we should expect, how wide our confidence intervals will be. So when you put a number here for margin of error, you are saying in effect that I am willing to accept confidence intervals that are this wide. So if I say a margin of error of 5, it means that I'm willing to accept that my confidence intervals will be 10 percentage points wide. So what does that mean? A confidence interval that ranges from, for example, 5 to, so you subtract the upper limit of the confidence interval from the lower limit to get the width. For example, in this case, the confidence interval ranges from 21.8 to 20.8. This is a very tight confidence interval. And you should be able to just look at a number and say, wow, this came from a very large sample size. These are some things that you should be able to tell just by looking at the data set, at estimates. Because these are very, very tight confidence interval, which tells me that, wow, this must have come from a very large sample size. You see how narrow they are, how tight the confidence intervals are. So the margin of error here will be 21.8 minus 20.8 divided by 2. That will give you the margin of error. So the tighter your margin of error, that means that the narrower your confidence interval will be. And the larger your margin of error is, well, the wider your confidence intervals will be. So here you're going to put the margin of error you're willing to accept or live with. Now, sometimes your studies are based on a budget. You get the funding of, let's say, $10,000. Well, there's not much you can do with $10,000. So you're like, okay, after giving incentives and doing all of those things, well, I don't have a lot more money. I can't recruit a lot of people. Well, life's about trade-offs. You can't have everything your way, right? So you need to understand that study design is all about trade-offs. You can't have everything. Nobody has everything in this life. So you must be willing to say, what am I willing to give up because I don't have enough money? Well, I'm willing to accept a higher margin of error. Or, in other words, I'm willing to accept a wider confidence interval for my estimates because I don't have money, right? So you must be willing to make trade-offs. And your job as a researcher is to understand the implications of your trade-offs for your study. So it's not just blindly making trade-offs. It's like making trade-offs and knowing that this is the implication that it's going to have on my study. So I'm going to accept the margin of error. I'm going to say, all right, we will cluster sampling be performed? In this case, I might say, yes, I want to perform cluster sampling. Now, when we're performing cluster sampling, we need to be mindful of also precision, issues of precision. Cluster sampling is very important, or the considerations about cluster sampling are important because your study should have a degree of freedom of at least 8, right? For you based on NCHS precision standards. We discussed this last week. The degrees of freedom in the survey is simply equals to the number of clusters minus the number of strata. Now, this consideration makes it very important for you because it helps you decide whether these people you want to study should be a cluster or should be the population as defined by you. Let's say I want to do a survey in 2 states, right? Let's say in state 1 and state 2. The question is, should I use those states as clusters? Well, that doesn't make sense, right? I only have 2 states. How will I, or let's say I want to make let's use Nigeria, for example. I want to do a survey of Nigeria or Western Nigeria, and maybe there are 10 states there, but I only have resources to go to 2 states. So I want to randomly select 2 states. Now, does that decision make sense from a scientific perspective? No, it does not. How are you selecting 2 states at random as clusters and saying it makes sense? It doesn't make sense because your degrees of freedom are less than 8. Your study is not going to be precise based on NCHS guidelines. So that should force you to say, oh, okay, maybe instead of treating those 2 states as clusters, I should define them as my population. Now, there are trade-offs. Obviously, the trade-offs here are that I won't get to make inferences to the whole of Nigeria or to the whole of the western part of wherever I was talking about originally. I only get to make inferences to 2 states. And that's fine, right? But now, having defined them as my population, I can get to sample maybe all the local governments there. I can get to sample more local governments, a whole lot more than just 2 local governments, right? I can maybe sample 15 local governments. So that is how, this is the kind of trade-offs you need to be aware of. Like, when do you need to switch from thinking about a location or locations as clusters and switch to thinking about them as your population of interest, right? Those are important things you need to worry about. So here, you choose the study design, you choose the level of confidence, you select the prevalence of the outcome. If you don't know what the prevalence is, you can leave it at 50%. What is special about 50% is that at 50%, if the binomial distributions assure us that you're going to have the maximum polarity. Think of it when we say a country is divided or a country is highly polarized. It means that, well, half of the country agrees on one thing and the other half disagree on that very same thing. So when you have half in one direction and the other half in another direction, you have maximum variance or you have maximum polarity or maximum disagreement. It is not maximum disagreement if 90% of the country says, yes, this is the good way to go, and only 10% say, no, that's the bad way. Well, that means the country is very united, right? Variance is maximized when it's an even split, half and half. Well, statistically, it's the same thing. We get maximum variance when 50% say this and 50% say that. So that's why we use 50%, because this guarantees us that at the maximum variance, we're going to get the maximum sample size. And this is a case of like, well, we don't know exactly how many people we will need, but let's just aim for the highest possible, just so we are covered. That's what you're saying in effect, right? Because you might have many outcomes in your survey and you want to make sure that your sample size covers all of them. That's why we end up using 50. So again, it's not just about plugging in values and having a result and saying, ta-da. You need to understand the statistical basis for those numbers as well and why we use them. And so here I say, okay, I'm going to use cluster sampling and I have to provide a design effect. Take note that this word is very similar to another word called effect size. They both have the word effect in them, but they are very, very different. Design effect arises because we use cluster sampling. Because of our design, we've designed the study in a way that it uses cluster sampling, right? And because we're using cluster sampling, there's an effect of this design on our sample size, right? People who are from the same cluster tend to look alike. If you sample people from the same household, maybe they have a lot of preferences that are similar, right? So the idea is that our sample is not looking so diverse because it comes from clusters where people look alike. And so question is, how do we correct for this? Well, that's what a design effect is. That's its job. The job of a design effect is to punish cluster samples because they look alike, so that it allows us to get a larger sample than we would have. So the design effect is one when we have a simple random sample. But when we have a cluster sample, we have to obviously increase the design effect. Let's say we were going to go with design effect of 1.5. A number of strata. Here we are talking about how many strata do we need. If you're not familiar with strata, you want to watch out for it. We're going to have a session on this very soon. We're actually having a collaboration with the University of California to have a session on national survey design. So if you're interested, you should definitely come to that session. We're going to put out the flyers very soon. So you definitely want to make sure you're there. So number of strata, the margin of error, and the anticipated response rate. This is within your control. There are things you can do to increase the response rate. You can give incentives. When you give incentives, people generally are willing to take your money and give you their answers. Everybody's time is precious to them. So you have to think of, how are we going to engage them? Am I going to go to the community and engage the local stakeholders? Am I going to give non-cash incentives? What are you exactly going to do to increase response rate? So let's say that I hope my response rate is going to be 50. Please don't be over optimistic when you're putting those parameters. Be realistic. And there's no magic number you can plug in. All sample sizes are wrong. So we need to understand that every sample size you ever calculate is wrong. It's just an estimate. It's a guesswork, but it has to be a guess that makes sense, right? And then you click on get results. It takes those parameters, and based on what you've put in there, it tells you that, oh, this is the sample size you need. Now, one of the things you should do to better understand these concepts better is try and adjust the sample size, the parameters here, and just study the impact and see what impact it has on the sample size. So for example, if I say, okay, I don't want a margin of error of 10, I want to reduce it to let's say 5. What impact do I expect? And before you even see the result, you should be able to guess, in a predictable manner and say, okay, I think that if I reduce the margin of error from 10 to 5, I think my sample size will increase. You should also be able to theorize on why that will happen. This is how you become a master of study design, right? So play with this. Your homework is to really play with these elements today. And before you see a result, try and make a guess that, oh, I think that the sample size will increase because of X, Y, and Z. And then you can see whether your assumptions were correct or not. That's what I would really encourage you. So for those of you who say we don't give homework, well, that's your homework for today. Try and play with it and see how that happens. So these are some of the considerations you pay attention to when calculating sample sizes for descriptive studies. Now let's quickly look at analytical studies, and let's look at what are some of the things you would want to consider. So let's look at comparative study with 2 arms. Next week, we'll look at 3 or more arms, but for today, for simplicity, let's just look at some of the simple cases. And I'll also encourage you to look at the other advanced studies. How about studies where you have 3 or more arms and you want to, control for multiple comparisons as well? Remember, we talked about, scenarios where you can have type 1 error, right? I would say the most common reason is multiple comparisons. So how do you control for that, accordingly? So these are some of the things that you want to try your hands on. But like I said, for this scenario, we'll just go ahead with comparative study with 2 arms. You select the kind of study you want, whether it's case control, retrospective cohort, prospective cohort, randomized trial, and all that. The different study types have implications. Obviously, there's a reason why we separated them into the different types, because there are implications for sample size calculation. For example, when we're doing a case control study, we'll generally recommend that the ratio of controls to cases be 4:1. It's not enough for you to just know that, oh, well, it is generally good practice to have 4 controls for each case. Why? Why do we recommend that we stop at 4? Why not 5? Why not 6? Right? Why? So those are some of the things that it's not enough to just plug in numbers and get results. you also want to understand the scientific basis behind those decisions. Because here we provide hints, right? There are hints provided clearly. So if you aim for balanced numbers between the two study arms, enter a ratio of 1. Otherwise, enter the number by which you want to increase the sample size in one arm. Keep in mind that increasing the ratio of controls to cases beyond 4 provides little additional benefit in enhancing study precision. Right? So the question is, why? So you need to ask a lot of whys to become an expert in study design, as opposed to just taking whatever hints that have been provided. So here, you choose a study type, you provide the prevalence of outcome among the control group. Remember that this is an analytical study or comparative study. We're comparing two things, right? Comparing two things means that you need to know at least what to expect, what to hope for, right? So the prevalence of the outcome among control group, let's say I think that the prevalence is 25%, and I think that I want to see an odds ratio of at least 1.5 between controls and cases. My level of confidence is 95, and this is a two-sided test. Always go with a two-sided test, right? Two-sided test means that I'm willing that the result will go this way, but I'm also open that it may go the other way around, right? A one-sided test means I have made up my mind, and this study must go this way. That's a very unhelpful way of looking at research, or even looking at life in general. You have to be open to options or open to possibilities that you otherwise imagined. Then you have power here. Power, remember, is 1 minus beta. So here, let me pop quiz. What is the level of beta here now? Given that the power is 70, what is beta? You can type your result there in the chat. Let me see if at least, awesome. All right, great. So we've been following. So power is 1 minus beta. So then ratio of controls to cases. Let's say I want 4 controls to each case. I have my this, and then I can calculate my sample size accordingly based on this and look at the results. So now I know that I need 29 cases and 113 controls, or a total of 142, and that is a reference for the sample size calculation. So I'll encourage you, again, please try and practice, and try and read more and see, okay, why do I have 4 options here, right? Prevalence of outcome among cases, I have absolute prevalence difference, I have odds ratios, I have prevalence ratio. What's the difference between odds ratios and prevalence ratios, right? And why does it matter? Those are some of the questions that we need to ask to become, experts in our crafts as researchers. All right, so that's what we're going to stop today. Next week, like I said, we're going to focus on how do we interpret results from regression analysis. Today's focus was purely on p-values, because that's such a misunderstood concept, and how we can avoid errors that are related to type 1 and type 2. So I'm going to take questions that that have not been answered at this point.
Oops. Why are we calculating sample size without knowing the population size? How are we sure that the sample size estimate adequately represents the population parameter?
Because sample size is agnostic of population size. The sample size, remember we said, sample size is like tasting soup. This is the analogy we gave last week. You're cooking a pot of soup and you want to taste the pot. Well, the amount of soup you're going to take to taste doesn't matter. It doesn't depend on the size of a pot. It doesn't matter whether the pot is like super, super big or super small. You are still going to take the same small amount to taste. Your goal is not to eat the whole pot, obviously. If your goal was to eat the whole pot, then the size of the pot will matter. Your goal is to simply take a sample. And as far as you steer the content of the pot, you're covered, right? So sample size, another take-home point, which we really, really must emphasize, is that sample size is not determined by population size. So, so if we put this number here, this is a very poorly misunderstood concept. But as we increase the sample size, see, the sample size will remain exactly the same. So We don't need to know the sample size. The only time the population size matters is when we have a very tiny sample population. But as far as the population is very large, well, it doesn't really matter. The sample size will remain exactly the same, regardless of the population size.
Can I use case control for my undergraduate final year project work? Association between blood group type and developing infectious diseases.
You can use a case control. You can use a study. The context matters, right? One of the things we're actually planning to do is to have a hackathon where we want people to bring their but please, the study designs the questions have to be very interesting and complex questions, and where we can design them in real time, right? So it's not enough to just say, oh, this is how you design studies. Like, well, let's design them in real time, right? So we're going to put out an announcement for that for folks who want to participate. And it's good, even if your proposal is not the one that we're going to review, you should still come and see how we go through issues of design and what practical considerations we have. So when we create the flyer, we're going to post it and we're going to ask for a call for proposals. The requirements will be that the questions have to be don't submit proposals of, oh, I want to do a survey in the village to look at prevalence. That is not interesting in any way, shape, or form, right? We want really complicated study designs that allow people to learn from and that test the borders of epidemiology, right? That's what we want. So yes, so we're going to put that out and so you can, but as far as your question, yes, you can design whatever, you just need to know what the case control study is, obviously, and how to frame your study within the context of case control. So we'll put a flyer and you can definitely pitch your own proposal, and who knows, we might consider it. But like I said, we're looking for complicated designs that provide a lot of meat to discuss substantial issues in epidemiology. Our next question, please.
Shamsuddin.
All right, thank you. Thank you, Prof. So I just want to ask a question around the sample size stuff. Please correct me wrong if I didn't hear you correctly. You mentioned that no sample size is correct, so I'm still processing that. I'm trying to internalize that, and that begs the question as to why then, if all sample size are not correct, so why do we then have to calculate the sample size that we want to use? And that also would like to I would like you to also shed more light of why determining the power of the study if you don't get anything because it's wrong anyway, whether you do it or not, it's wrong. So I just want to understand, why do we have to calculate the sample size then, and why do we have to determine the power of the study? The last part of the question is, I just want to pick on your wealth of expertise. What do you think will be the best trade-off? My understanding of the type 1 and type 2 error, there's always has to be a trade-off to balance the two. So I just want to pick on your brain. What do you think is the best decision? At what point should I see I should go more with type 1 or less with type 2 and all of that? So I just want to get your idea on that. Thank you.
You're welcome. So that's a very good point. The first question is amazing, right? Like, why do it? I think it falls along the same lines as questions like, why do we plan for tomorrow? Like, none of us is sure that, none of us are sure that we're going to wake up tomorrow, right? There's some element of planning is more around, it just hinges on the stochastic, right? There's always a probabilistic element to whether we're going to, it's not certain, it's not guaranteed, but we still plan. We still say, okay, I'm going to, because it makes more sense to plan than not to plan, Now, when we say all sample sizes are wrong, it means that there's no objectively true sample size. So it doesn't mean that it's unhelpful to calculate sample size. But you can, and it's more to also help us appreciate that research design is about context. We don't want to stand on a hill and say, oh, this is correct and I'm right, because like nobody's right. We're all wrong. Right. So it's still in that sense of uncertainty in us, because research is all about uncertainty, that there is no absolutely true correct answer. All we are doing is coming up with a rough number that that more than increases the likelihood that we're going to get what we want, right? So In other words, all of these things are assumptions. When you say, oh, anticipated response rate, like you don't know what the response rate will be, you're just saying, okay, I'm just going to put a number there to manage the risk. When you say, okay, the design effect will be this, well, you don't know what the design effect will be. You might get something from previous studies, but well, no two studies are identical. It's like no two kids in the household are identical either. So the point I'm trying to make is that all we do here is just like, it's all about risk management. I think it's helpful to look at it from that framework, right? If you run a company or you run a business, like, okay, risk. What are the risks that we face and how do we mitigate those risks? Well, we can do this. So in this case, like, okay, we don't want to take all our time and money and energies to go and conduct a study and not even have any idea that it will go the right way. So at least let's get something. Something is better than nothing, right? But I think it's very helpful for us to have that mind frame so that we are more cautious. We think deeper about what we're doing, knowing that there's nothing guaranteed. And that allows us to be more intentional about what we do. We also understand that everything is about trade-offs, right? By doing this, we're not doing that. And by doing that, we're not doing this. So when we think about things through the framework of trade-offs and about which is more appropriate as opposed to which is wrong or which is right, I think that's a mental shift we really need to move away from. If we're sometimes fond of saying, oh, this is wrong and this is right. Well, in most cases in life, it's not that simplistic. It's more about, is this more appropriate in this context or is this less appropriate? So one really move away from just categorically saying that something is right or something is wrong, because it doesn't reflect that that maturity we'll expect from researchers who understand that it's all about context. So we calculate sample size still too, because it's better than doing nothing. We can't just at least we're saying that given this context, if these conditions are met, then this is the number we will expect to give us this result. Now, of course, you will go out and find that the conditions under which you calculate a sample size are not the ones in the real world. Mike Tyson says everybody has a plan until they get knocked out in the teeth, right? You have your own plan for what you think the conditions will be, but you go to the real world and realize that they're quite far from different. So what happens? Well, it's still better than not having a plan at all, right? So that's the point we're trying to make. So it's about understanding that it's not a clear field, and we need to be very intentional about what we do, because it's at the end of the day, it's about educated guesses. Now, about type 1 and type 2 error, which direction should we go? So first, I want to make sure we all understand that sometimes we imagine that you can only have one of those two things, that you can have type 1 error or you have type 2 error. Oh, well, most times they exist together in the same study. Imagine you study, this guy is doing a fishing expedition, and at the same time, he's doing a whole bunch of subgroup analysis, right? Well, it means that just because he's doing a whole lot of subgroup analysis, it means that he's very likely to find something just by chance. And because the subgroup analyses are small, it means that he's not going to find significant results in quite a number of groups, because even if there was a significant difference in those groups, just because the sample size is so small, by having taken a small chunk of a big population, you will not find anything. So we need to first of all understand that it's not a clear dichotomy of, oh, this is type 1 error and this is type 2 error. They coexist in both space, and so which direction then do we go? Do we need to try and avoid type 1 error, or do we need to avoid type 2 error? It really depends on the space. In general, public health is built on a precautionary principle. We try to say that we want results that are conservative. Conservative results in general means that, well, we prefer to be wrong than to be right. We prefer to say that the drug does not work than to say the drug works, right? So any day, anytime, when lives are involved, we would rather be on the side of caution and say that, oh, this drug does not work. At least we can go back to the drawing board and try again, rather than put out a drug that we claim works while it's just killing people. So in that environment where the issue of risk is high and the outcome is serious, we obviously want to prioritize minimizing the risk of type 1 error over the risk of type 2 error. But if it's a business environment, let's say entrepreneurship, we encourage entrepreneurs to try and fail, right? Go out there like a type 1, like an alpha, and make mistakes and just grow and it's okay. You can learn from your mistakes. In that kind of context now, we are saying we prefer you making a type 1 error than just hiding in timidity and saying, oh, I don't want to try anything. I'm afraid I'm going to fail. Like, no. So at the end of the day, again, it's all dependent on context. Like, what are the risks involved? Is this a life and death scenario? Can we afford to live with a bad outcome? And what is this bad outcome in the first place? Then we can now decide whether we are willing to accept type 1 error or whether we're willing to accept type 2 error. So it's all contextual.
Dr. Stephen Ojo.
Okay, thank you, Prof. I presented this null and the alternative hypothesis. I'll just read it out, and I was queried that it should be the other way around. I said my null, which is the HO, is a Chrysophyllum albidum fractions, has no significant anti-biofilm and anti-persistent effect against Clostridium Clostridioides difficile infection in units. That's my null hypothesis. And I said the alternative hypothesis is Chrysophyllum albidum fractions has significant anti-biofilm and anti-persistent effects against Clostridioides difficile infection in units. But the question that was asked was that why would I use the positive significance for my alternative instead of making it my null? But with what you explained, you said for null hypothesis that it is nothing significant. We're bringing out nothing from any significant thing. So I want to ask whether this my hypothesis actually reflects what you explained to us in this training this evening.
Yeah, you're correct.
Okay.
So you have to go and ask those who told you are incorrect to explain themselves. So you can ask them respectfully that, could you, or maybe you can avoid that so that you don't sound confrontational. But but you're fine. You're correct.
Okay, so I want to ask that, is it in all cases that our null hypothesis should be from the positive, maybe using my my H1 as my HO? Because that is what most persons always report, that it has significant effects as against the target organism.
So what might be throwing off the people who critiqued you is what you said, no significance. What they might have expected to see is to say that there's no difference between the treatment and the control in the effect or whatever effect, or that there's no mean difference. Maybe that's language they were expecting to see, but at the end of the day, it's just really it's really potato. It's just semantics. When we understand it at the core of it, whether you say there is no significant association between A and B, or whether you say there's no difference between A and B, or whether you say that the means of this group will be the same as the mean of that group, you are really saying the same thing. There is no, what we'll say is that try to make sure that your alternative hypothesis is not necessarily stacked in one way. So, what we're saying is this. You say that you should frame your alternative as being a two-sided hypothesis. So in your case, you said there is no association between A and B. I would say that you can say that in a million ways. Now, one of the things I also encourage you to do is to practice taking one concept and saying it in 1 million ways, right? That we can say this in a million ways, like we said. We said you can say there is no association between A and B, or if you're looking at means, the mean value of A and B are no difference, right? Or we can say that mean of A equals mean of B, in all of this, we're saying that nothing interesting is happening here. That there's nothing special about mean of B, or that it's nothing interesting, it's nothing out of the ordinary. Now, the alternative, here is a way I would not encourage you to say it. If you say that the mean of B is greater than mean of A, well, this means you've set up your study to look at it in one direction. You said it's greater. Well, so it's better to frame it in a way that is two-sided. So that means you're going to say mean of B is different. Different could mean it's greater or it's less. You're willing to look at both sides of the equation, right? And that's what research is all about. Research means that we are opening our mind to accepting whatever comes from the data, right? We will just follow the path and we'll see what comes out, right? So you can frame this in a million ways, and so it still makes it right, right? Now, the second part of your question was, is it every time that we frame the null in this way? No, it's not every time that we frame it this way. In other types of studies, we frame it quite differently. And we need to understand why that happens, right? For example, if we're conducting a non-inferiority trial, right? Non-inferiority trial says that drug A is no worse. This is a statement that we want to come out and say at the end of the day. So imagine that I am the CEO of a pharmaceutical company and I've developed a new drug. Let's call this drug A. This is a new drug. No worse than drug B. And drug B is the standard of care. All right. I've developed a new drug. So remember that, let's keep this in mind. The new drug is drug A and B is standard of care. Now, this is a new drug. All I want to do is to come out and say, oh, our drug is no worse than drug B. It's not inferior to drug B in terms of, this clinical outcome. But I still have to do research, right? I'm not trying to claim that it's better. It's just to say that it's no worse. Now, the null hypothesis cannot be that drug A and drug B are the same, because that's the very statement I want to prove. I want to prove that these two drugs are the same. So the null cannot be that drug A is equal to drug B, because think of that, right? If that was my null hypothesis, I would just go and conduct the sloppiest study and get 2 people in this arm and 2 people in that arm, and I will not see a significant difference. And I'll say, yay, our null hypothesis is true, that drug A and drug B are not the same. That we can never allow that to happen, right? So the null hypothesis in a non-inferiority trial is different, right? The null hypothesis in a non-inferiority trial, so your hypothesis here, let's just put it in a casual way so that we can see the difference. So this is no difference null. And in the alternative, we're saying there's difference. This is the null and alternative here. Here we're saying that drug A, I'm going to use very casual language here, sucks compared to drug B. So, in other words, it's inferior. That's what we're saying in standard language, right? So this is very important to note, because now as the researcher, I am, as a drug, manufacturer sponsor, I am suddenly very motivated to prove that this is not true. That drug A sucks, drug A, this is my drug, sucks compared to drug B, or is inferior, if we're using standard language, right? Because what does this prevent? It prevents me from getting a small sample size and doing a very sloppy study and coming up with a conclusion, right? And so I now have to make sure that my sample size is really large and sufficient so that I can demonstrate that the alternative which is drug A, is non-inferior to drug B, which is alternative. So in different circumstances, the sample size, the null and alternative hypothesis could be different. And you need to be able to calculate the sample sizes accordingly. So in this case, you would come to non-inferiority trials here. See it right here. And there are some things you'd have to specify. First of all, prevalence of outcome among the control group. So if you look at the hint here, it says, enter the anticipated prevalence of the outcome, the control group, which represents the standard of care arm in your study, right? So I expect that, let's say, 25% of the treatment group, let's say 35% of patients who receive the treatment group get well. Now, the level of consistency is 95. My power could be whatever I set it to be. Let's say I want 90% power, because I know that if I go ahead and get a small sample size, I will get punished because my study would show no difference and I'll defer to the null, which says my study sucks or my drug sucks. I don't want that, right? I want to make sure. So I'm certainly very incentivized to make sure that this study is done in a very good way. Let's say I want to get a response rate of 70%. Now, very important. This is a very important parameter to supply when we're calculating sample size for a non-inferiority trial. If you look at the hint here, it says the absolute prevalence difference defines the zone of non-inferiority, which represents the predefined threshold that specifies the maximum allowable difference in terms of prevalence or efficacy or whatsoever, where the new treatment can still be considered non-inferior to the standard of care. So now I might have to go to gather a bunch of doctors and say, oh, hello, doctors, you're experts in this area. What's the margin that you will consider a drug to be still non-inferior, even if it's not as good as the standard of care? And the doctors will say, okay, well, if you can get a margin of 10% from that one, then we can say, okay, well, it's non-inferior, right? So you define that margin and the sample size is calculated based on that margin accordingly. And so that's how you do that. So this margin is calculated, it's determined by professionals. So in this case, I know that I need 557 people in the treatment arm and 557 controls, right? Now, it's very important to also acknowledge that a non-inferiority trial is always a one-arm study for obvious reasons, because we are trying to assess non-inferiority. It is not the same as a superiority trial where we are open to looking at whether the results go either direction. Non-inferiority trials are unique because they are always single-armed, one direction, in a single direction, is the direction of non-inferiority. All right, next question.
For a retrospective cohort study, where a researcher has an idea of the number of records available for review, do you calculate sample size or power?
Yeah, so the sample size, so that's a very important question, right? Because I think there's a lot of misconceptions about retrospective studies. Now, let's say you're in your clinic, you know that, oh, I have 200 records. Now, that 200 record is not the final source of truth. Sure, that's what you have, but that's not the interesting question. The interesting question is what is really needed, and is what you have enough? So it's not that we just accept what you have as line, hook, and sinker and say, oh, awesome, you're good to go. Well, we need to do better, right? And those are some of the considerations that might force us to see, oh, should we now do a case control study instead? Because it's looking like this is going to be very complicated, right? That's some of the trade-offs that we need to have. Like, these are some of the practical issues we need to look at and say, okay, let's just do a case control study instead, because it's just maybe more efficient than this, right? Because now we have, let's say you have 200 controls, you have 200 cases of, let's say, tuberculosis, and your research question is there an association between XYZ and diagnosis of tuberculosis, right? You have 200 cases exactly. Well, the challenge is that if you're doing a retrospective cohort, let's go back now and look at the sample size. Let's say you have a comparative study with 2 arms, percentage as controls, and we're interested in a retrospective cohort study. Now, remember that in a retrospective study, what we are calculating for is the sample size for exposed and non-exposed. What you have in hand may not be exposed and non-exposed. What you have in hand is cases. People who have the disease. You are working in a hospital, so you have counted, oh, I have 1, 2, 3, 4, I have 200 case notes or case records of people who have the disease. But that's not really what is interesting for a retrospective cohort study. We're not interested in the cases just yet. We're interested in people who were exposed. So we have to go back in time and see how many were exposed and how many were not exposed, right? So here we say, all right, what's the prevalence of the outcome among the non-exposed group? So, let's say your research question is the relationship between smokeless tobacco use and tuberculosis. That's what you're trying to research. So you need to look at, okay, among those people who do not use smokeless tobacco, what's the prevalence of tuberculosis, right? And so let's say we say it's 10%. Now we have to now say, okay, what's the minimum odds ratio or difference that we want to detect between the exposed and the non-exposed? So let's say we enter a prevalence ratio of 1.5, and we want to do a two-sided test, and let's keep this as 1, and the anticipated response rate is, let's say, 30, because we still have to go and recruit individuals, not just those who have our cases. So based on this, these are very, very stringent requirements. This is what happens when you have a very rare disease, right? If you now bump it down to 25, again, play with this and see how the results change when you change parameters, right? And the smaller the effect size you want, the smaller the difference you want to detect, the larger the sample size, obviously. So if you say, okay, well, 1.5 is a very small effect difference that we want to detect. Let's say we can live with an effect size of 2.5 as our prevalence ratio between the two groups, right? That would obviously reduce the sample size dramatically. So now I need 33 exposed or 393 non-exposed, and you make those decisions, and then you can see, okay, do I really want to go down that route? In general, my recommendation is that when you are dealing with existing cases, if you are a clinician and you have a X number of records from your hospital chart, and you want to do an analytical study, it's almost always just easier to do a case control study than to do a retrospective cohort study. Because remember, the first question you want to ask yourself when you're trying to decide between a retrospective cohort study and a case control study is, what do I have in my hand right now? What am I holding right now in my hand? If I'm holding the case notes of people who already have a disease, then why am I trying to do a retrospective cohort study? I can easily just do a case control study because I already have the cases well defined. And it's just easier. It's unless you really you like to suffer, it's just there's no explanation for why you would want to go and do a retrospective cohort study in that context where you already have the cases well defined and in your hand. So these are some of the considerations. Now, I'm not saying that it's wrong to do a retrospective cohort. I'm just saying that it's just not efficient in that context because you already have the cases in hand already. So I think it's, a lot of folks will benefit from when we do that hackathon I mentioned, where we'll have challenging study designs, and we can go through them together to see like practical considerations we need to pay when we're designing some of the studies. All right, next question.
Okay. On Nusulu, Daniel. Okay. Let's try Abu Bakar.
Hello, hello.
Okay.
Hello, almost good. Okay. Thank you, Prof, for the wonderful lecture you've been giving us. I can never be tired of listening to you. Please, on this issue of sample size calculation, please, can we try using two groups where the outcome we are comparing the quantitative? Let's say we want to compare mean difference between two groups. Because I had a challenge trying to use this because the issue of maybe absolute
standard deviation values and standardized effect size and all that, because sometimes when we try to enter the raw standard deviation the way it is, it gives a very insignificant value. So please, I think when we do it, then the challenge that I had will be possibly made obvious. Thank you, sir. Don't know.
So what kind of study is this? Is this a comparative study or is it a
comparative study with two arms?
Okay, all right. So let's say you're designing a prospective cohort study, and the different. So what's the difference in means that you want to assess?
Now let's say difference in mean of 100 mils of blood loss. We're comparing blood loss in two groups. One has 200, 300 mil. That's a control. One I want to see if a particular intervention will reduce the blood loss to say 200 mil. So the difference is 100 mil of blood.
Okay. So what's the standard deviation then?
Yes, that is like in that particular study, in a particular study we're referencing, the total blood loss in one group was like 237 standard deviation plus or minus 23 mil or 34 mil, let's say, for instance. And then in the control group, it has about 30 mil, plus or minus 30 mil. I don't know what.
So when you enter those parameters,
so we enter these values as raw as they were, and we had some.
So this is telling you that the standard deviation you are entering here.
Yes, this is the kind of thing we got.
Okay. Now you have to make sense that so in general, what would you consider as the range of blood loss? What's reasonable levels of blood loss, like, from what you understand, right? What could be the range?
It could range from 100 to 200. Let me just put it that way.
Okay, but you see, the more the standard deviation, right, would have a clear impact. Now, this is where it can be tricky because you don't know what the standard deviation is for your population, because obviously there's a difference between if you enter 2.5 as standard deviation, and if you enter, for example, another value, like let's say 80, right? You're going to get dramatically different results based on what has been entered. So the question is, what is the true range of blood loss in an individual who is still alive? Well, it could range from 0, right? There's no blood loss at all, to what level? Like, what level of blood loss is consistent with reality? Because that's what the true standard deviation is. So the problem might be that you are entering a number for a wrong input, the wrong input for the right, one way to look at a standard deviation, if you don't know what the exact value is, look at the general values in reality and divide them by 4. We call that the range rule of thumb, because the idea is that, the entire range lies within 4 standard deviations, right? So if you look at the full range of possible values that are consistent with reality, and we divide them by 4, that gives us an idea. Now, that's just a rule of thumb, obviously. It doesn't replace getting the actual value. But then we can then compare that value with what you supplied and say, okay, does it match up, right? So let's look at that exercise, right? So the range of possible blood loss could be that I did not lose any blood, which is 0, to, well, if the individual lost, you said the other range was 200, right? That means that some individuals lost up to 200 mils. And it's also possible that some lost even higher. So the true range could be much more than you've provided. The true range could even be something from 0 to 300 mils or 0 to 400 mils. Now, if that's the case, the range rule of thumb tells us that the range divided by 4 gives us an estimate of what we should expect for one standard deviation. So in this case, if we're going with, let's say, 400 mils, which is like the full range of the possible values, 0 to 400, 400 minus 0 is 400. 400 divided by 4 is 100, right? if I entered 100 now as that range, I'm going to get obviously different results, right? So you need to actually estimate, like you need to understand, first of all, what the true standard deviation is for what you're measuring. And, you know, and then calculate it accordingly. So, just so grabbing the value that you found from from source material might be useful, but may not be really relevant to the research question on hand. If your question is about blood loss in general, the question is, what is the true standard deviation? So if you enter a wrong number, and as researchers, right, we should be able to look at the number and say, oh, sure, I got this number from the paper, but this doesn't make any sense. Like, I don't know what the value is, but there is no way that the standard deviation for a metric will be this low, given what I know about the range, right? So I may not be into blood loss, but I should know that, okay, if I know that a range of blood loss could range from 0 to 400, then it is not possible. It is mathematically impossible that the standard deviation will just be 20. It doesn't hold up to the water. And so that means that if I put a value here of 20, I'm going to get obviously wrong results, because the number I have put here does not match what I have put in the standard deviation. Now, if you are still unsure, the best thing for you to then do is to just go the safe way, right? Because you may not have all the patience and time to be making all the statistical considerations to yourself. So in that case, just go with the percentages. At least the percentages, the chances of you going wrong are less. So, because if you don't know, well, just, it's easier to make mistakes when you're dealing with means and standard deviations, because you don't know what you don't know really. And sometimes it's hard to know even the true range of the actual values. I hope that answers your question.
Yes, Prof. Yes. Thank you, Prof.
You're welcome. Okay, I believe we've answered all the questions, Lungile.
You answered 4 questions, Prof.
That's like,
yeah, just 4 in 2 hours. Abubakar.
Oh man, the standard deviation is, I think you're calculating the standard deviation wrong. Oh, that's funny.
Yeah. Is it okay to present a proposal that is AI generated, or you have to humanize?
I generally just stay away from answering this question, because it's like, what is AI generated? If I want to engage with some material, I want to engage with a human. It's fine to use AI to help you with the content, but not that you just some AI generated everything for you. So if you're asking me whether I want to engage with an AI content, no, I don't want to engage with AI content.
Christopher.
Thank you for your lectures. Please, I just want to ask, this Chi-square platform, can it be used to calculate sample size in animal studies, or just for human?
Sample size doesn't matter whether it's humans or animals or cars or whatever, it's the same thing. So yes, you can use it for that.
Thank you.
You're welcome.
And Prof, someone asked the same question, but for hospital studies.
Yes, sample size is agnostic of it doesn't really matter. It's like the unit of analysis does not have no bearing on it.
Okay. How do we create p-value? Number 1. Number 2, a case where we don't have p-value. How do you interpret such results? Number 3, what advice will you give to undergraduate students, L100, having the idea to conduct a research on blood group type and its association with infectious diseases, more especially TB and multi-drug resistance? Number 4, and also, how can I calculate sample size for the study since my data will be collected at the hospital?
Okay, so how do I get ideas? So I'll encourage you to go to the Chisquares platform and go to the AI toolkit and help it. You already have some ideas. So let it help you generate some ideas. So go to AI research question generator and type that idea. So your idea was the relationship between blood group. What can you read the third question, please? Lungle.
What advice will you give?
No, the third
Having
question.
blood type group and its association with infectious diseases, more especially TB and multi-drug resistance.
And the association with tuberculosis.
Yes, sir.
Especially what?
Especially multi-drug, TB and multi-drug resistance.
So just type whatever you want to type. It doesn't have to be eloquent. It doesn't have to be nice. Just type it there, multi-drug resistance. So this is what you just said exactly. So just go in there, enter whatever it is, and it will help you think of research questions that you could ask that will make sense, right? And so once it does all of that for you, it's your job as a researcher to now go through the material and say, okay, wow, I really like this and this. So I'm going to develop those ones further, right? Of course, AI cannot stand in for you. It's your job to make evaluations and finally make the decision for what you want to do with your research. But the AI toolkit, what it does is that it helps you to at least streamline, takes that rough idea you have, and it helps you polish that into research questions that you can then explore as part of the research. So that initial part of brainstorming, it can help you with that, So that way, you can then proceed with choosing which one you want to go with, and then doing your research. So that's what I would recommend. Now, the sample size calculation is also related. We can calculate the sample size the same way so let's go back to that field. And we'll come back to this in a second. So the sample size will be exactly the same as we did for this, right? You choose the sample size and you determine it accordingly, based on whether we want our study to be descriptive or analytical. But all of that depends on what you finally decide to use from what has been suggested. So when you look at the suggestions, whenever it's finished, it takes a few minutes sometimes. So you look at that and you streamline your choice, and then you can go from there. But it first of all boils down to determining what we want to do first. And then once we have decided, we can then make the other decisions.
I'm working on oh, sorry, Prof. You're still speaking. I'm working on patronage patterns of hair salon businesses. So who do I use as a sample? The female customer or the female hair salon business owners?
You can use whatever you want. It depends on what your research question is. But the goal of what we're trying to say is that you should feel empowered to think freely of what am I trying to answer. Those kind of questions, you're the only one who can determine, because it's what you want to answer. So nobody else can make those decisions for you. So you can decide to use any of them or even both of them.
Can we publish a study with your team by collecting data online?
Well, you don't have to publish with us. If you collect data, your data is your data. You can do whatever you want with it.
Can they do it with your team?
Sure. My team, you can ask my team, and Lungile is here. Okay, Lungile, please answer the question.
It was directed to you. Moving on. What really needed to calculate the urban crime pattern?
Sorry, I didn't get that question. Can you read again, please?
What's really needed to calculate the urban crime pattern?
What is really needed is your input. So you have to figure out what. Yeah, you have to figure out what you want to answer. You have to figure out what you want to ask, and then proceed with that. So we already provided so if you want to calculate the sample size for the, that's a very broad question for now, right? So let's look at this. So you have to first of all streamline that question into a well-defined research question, and you can come and do that here, right? saying urban crime patterns, that's a broad statement. It's not a research question. So first thing, you have to come and figure out what your research question is, right? So for example, this is what we did with that other question. The research question was, blood types and association with tuberculosis. This was a statement, remember? Well, we've taken that statement and we have turned it into a research question. Like the question is, say, is there an association between blood type and the prevalence of tuberculosis, right? And then it looks at specific aims and objectives. It also goes ahead to suggest other possible research questions that we can explore. And you can decide to pick any of those to research. Now, when you have done this, then it's easier to say, all right, this is the direction we'll take it. So your input is still needed in refining the research question to something that is a bit more well-defined.
Thank you. Hi, Prof. I'm looking forward to collect data in a town with more than 4 million people. How do I calculate the sample size in a cross-sectional study?
Well, it's exactly the same way we did it. Yes, the 4 million people doesn't matter. The population size is, doesn't influence sample size calculation. So you can just go to the platform and do exactly what we did.
I'm sorry, everyone, if you want me to, if you posted questions much earlier, please post them again. Okay, Prof, any correlation between confidence interval and standard error of mean?
Yes, we're going to talk about, like I said earlier, we're going to talk about the relationship between confidence intervals and standard error. But it's also something you can also read ahead of class before next week. But the idea is, how do you calculate, how do you convert? You should be able to comfortably convert between confidence intervals and standard errors, between standard errors and p-value. That's something you should be able to do conveniently. So yeah, obviously there's a mathematical association between all of them.
I need an explanation on census techniques and data collection.
That's the whole PhD. So we will not cover it in this class. We have to look at some, we may have to look at a whole census for a whole country. Well, that's way beyond the scope of this lecture. But we'll have some sessions on data collection, and and you can definitely attend those too. Like I said, we're having a partnership with the University of California to have a course on design of national survey. So you definitely want to register and attend that. We'll put out the flyer very soon.
Okay. There was an announcement on a course of tech, public health, and EP. Is there any feedback?
Yeah, we'll share the feedback. We're still working on a lot of things involved on that. There's a lot of curriculum components that need to be developed.
I'm working to collect data on 7 wards in relation to urban crime types: burglary, murder, robbery. Okay. It's unfortunate that you seem to, can you unmute yourself, Abu Bakar, so you can explain further? Okay. But yeah, Prof, that's just continuation of the question. Okay, there you go. Abu Bakar, you can ask.
Hello? Hello?
Yeah, we can hear you.
We can hear you.
Okay. I'm working on analysis of urban crime patterns in one of the urban area in Nigeria. Trying to look at how those particular spatial distribution of urban crime patterns within one's urban area that has to do with burglary, kidnapping, banditry, armed robbery, car snatching, and so many other issues. These are the kind of the activities of the crime that happen in that particular area. And I'm trying to look at those particular areas as a cluster, look at that particular area as a planned and unplanned area. So I'm working on the particular area to look at how these particular urban crime activities affected the environment and how the crime patterns also will be look like. Because I'm working in the urban area and some of the urban area are planned and unplanned area.
Okay, is there a question somewhere in there?
Hello.
Yeah, I can hear you. Yeah, I can hear very well.
You said?
Is there a question somewhere in there? You just described the context, but so what's the question? Like
The question is
there a question in
is
there?
there any relation? I can't hear you well. I can't hear you well. The network is cracking.
Okay, I heard you. You described your study, but so my question is, what question do you have?
Okay, how will I analyze what kind of data that I'm require for me to analyze those particular crime patterns? Despite the fact that I have the burglary, the murders, the pot picking, the armed robbery as the indices for me to analyze in those particular area.
Well, you need to sit
because
down.
They are the indicators. They are the indicators of the crime.
Yeah. So I get you. So you need to sit down and you need to sit down and craft a questionnaire, right? There are so many ways you can collect data. You can collect data from questionnaires. You can collect data from police records. Like the police records might say, oh, in this every month, these are the number of arrests we've made, or these are the number of burglaries we've had reported. You can look at environmental data.
I already collect those data from some of them collect data from 2012 to 2024. The current data that are collected from different police outposts in that particular settlement.
Okay, so I'm now unsure what the real question is then. Is your question how to analyze data? Like I'm really not sure what the ask is. I thought
the question is how to analyze the data now.
Okay, are you familiar with statistical software?
It's how to analyze those data.
Well, you will have to take a crash course on basic data analysis with I don't know. Are you familiar with any statistical software? Like Python or R or Stata? That's your first step.
Okay.
Yeah, so you'll need to be able to do some basic analysis, right? And it doesn't mean that you have to go and learn to write code. There are lots of software that allow drop down and click. So you'd have to go and explore what software is able to use and use that for your analysis accordingly. Yeah, unfortunately, I don't have anything more concrete to tell you, but you'd have to, this is where you would have to now do a little more work to get insights from that data. All right, next question, please.
A fresh biotech graduate, can you recommend a research group to work with on any research for building a research profile with access to wet lab for doing research like that?
I mean, I don't typically recommend groups, so you'd have to look for groups that align with your interests and join. I generally would not recommend a group.
Could you share your comments on synthetic data? Is it something you can work with?
You can work with it, but you have to understand the limitations. You can work with anything in this world. You have to know what you're dealing with and what the limitations are, right? Synthetic data is just, think of it as modeling, right? But so what are the limitations? Obviously, the name synthetic tells you all you need to know. How generalizable will it be? So, so research should not be about pursuing trends so much as trying to get insights that can be applied and knowing what the limitations of our research are.
How do I reference sample size calculated from Chisquares platform in my study right?
There is the when you go to the sample size and you look at the sample size you've done, you have the option to let's show reference. You can see citation and you can copy the citation from there.
Okay, thanks. Please, can I get statistical analysis software from you? I've been trying to get my hands on one.
You can go to the commercial websites and buy one from any of the agencies. I'm sure there are lots of companies that sell software. So you can, it's not our job to recommend one software to you. So you'd have to go and you have to go and get yourself sorted out. Next question, please.
Can't you donate?
Is that a question?
Can't you donate? There are no more questions.
Okay. All right. Thanks, everyone. We look forward to seeing you in the next class then. Any other comments, Lungile?
Please, can I get the names of the software needed for my analysis?
You know, I'm not sure what you're proficient with. You know, there are several open source software. There is Python, there's R. These are all open source. So you can explore them, but you can also do a quick Google search to see what's available in your university. You can ask your university librarian. Those questions are more suited for your librarian, at your institution, than here. I don't know what's available to you in your institution, so I will not be able to know what to recommend to you. But if you're looking for open source software, well, there are very powerful software like Python and R that you could use for your work. All right, thanks everyone. See you next week.
Thank you so much, everybody.